All right, time's up. So let's review and take a look at strategy passage 8. And, well, just let's first cover a couple of primary points about the passage. Our topic is centripetal motion, right? The passage type. Now, this is a persuasive reasoning, right? Because we have 3 different arguments basically being laid out. And remember that for persuasive reasoning passages, the types of questions you're likely to get are involve evaluating the hypothesis or the arguments that are made in the passage. And those question types generally tend to be implicit questions, so be on the lookout for that. All right, now, first we want to decide whenever we see a passage, is this one that I want to do now, or maybe one that I want to save for later? So, how many people, show of hands, how many guys do you think would want to do this now? All right, I got a count of 8 hands for this. And what about later? How many people think later? Only 2 of you seem to think that this is a later passage. And why do most of you say now? So, John, why do you think now would be a good time to do this passage? Okay, you like the topic, right? Centripetal motion, mechanics tends to be on the easier side, or at least it's not something like quantum or magnetic forces that you may have less experience with. So if this is something that you're comfortable with, sure. What about you, Anna? Why do you think this would be a now passage? Okay, so not too much text, no complicated figures. So if that's something that you like, then you would definitely want to go do that. Now remember that this can change from person to person, so you're not wrong if you thought this was a later. Just remember that you don't want to have too many later passages stacked up at the end of the test. So you want to make sure, well, if you had the choice, you'd probably just do all of them later, wouldn't you? Or never, and that wouldn't be good because then you would not get any physics points on the MCAT. So, we've decided now, so this would be one that we would tackle now in this scenario. And so next, highlighting. This is kind of a tricky passage to highlight just because there are a lot of things that meet our criteria. So you want to make sure that you don't go too crazy with the highlighting. Well, numbers, right? So anywhere you see a number, you're going to want to highlight that. And so I did that here. The mass, the radius, where the woman's standing, the mass of the object that she's rotating on, the speed, etc., etc. So anywhere where I saw a number, I highlighted. And so the first paragraph has a lot, especially towards the beginning. Terms, familiar terms. There's static friction. There's pseudo-force, which may or may not be familiar to you, but that one's also italicized, right? So that's one that we would definitely highlight. And for the first paragraph, I also highlighted the 1, 2, 3 points there because they're introducing new stuff. Well, centripetal is familiar, pseudo-forces may or may not be, and angular momentum is also familiar. So all 3 of those would get highlighted. The words, not the numbers. I just wrote this up here as shorthand for you guys. All right, what else? In the second paragraph, which is on the first phenomenon, it says cause, so that's a causal word, obviously, so that gets highlighted. 10 meters from the center, okay, 10 meters from the center can also get highlighted. Then we get an equation that we know, but I highlighted that anyway, just because you're probably trained when you see an equation to highlight that right away, and that's fine. We're told that Fc is provided by the tension and the frictional force, all right? So that's super important if we get any questions on that. And then they tell us that T stands for the period. And we get another equation, which I put over here. Now notice another thing that I did as we're doing the highlighting. As I was going through this passage, there were certain equations that I wrote down, right? There were certain things I wrote down to make my scratch paper easier. So the first thing was I did write that equation. So I actually put it up twice by accident. So that you would write up right away because it's embedded in the passage. Then we have a figure here that I drew. So in the first paragraph where they're kind of describing everything, it's going to be a lot easier if you can just visualize it. So if we draw a simple figure, we can say, okay, there's a woman standing, she's 10 meters from the center, it's going at a speed of 5 meters per second, oh, and she weighs 100 kilograms. Well, that's a lot easier to visualize like this, and it's only going to take a second to draw, than trying to wrap your head around what they're describing. So that got put up there. As I highlighted the static friction coefficient, which was here, I'll put that down. And when they told us the centripetal force equation, which we already would have known from class, I also wrote that down as well as something that might be important. Okay, so notice how using your scratch paper like this is going to make your life easier later because you have all the things that you need right in front of you, all the equations all right there for you, as well as this nice neat figure which is simplifying things when you review your passage. Cool, so we're here now, paragraph 3, pseudo-forces in italics. I have a however, change of direction, therefore, a causal word. So those are pretty much the main things in paragraph 3. Finally, paragraph 4, angular momentum, familiar word. And then we have a couple of equations for angular momentum, and as per before, and as what you want to do on the actual MCAT, I wrote angular momentum equations back down on the scratch paper, figuring that they were probably going to ask something about this later. Okay, and then we get the moment of inertia equation there, the rotational inertia. And so I wrote down that equation, and the last thing that's on the scratch paper is when they described this situation, FC is provided by T and F. I wrote that down in equation form just because that's easier to work with. Okay, finally we're told that LW plus LP is constant, right? So that's conserved. All right, so that's the highlighting. Again, a little tricky because a lot of things that we are trained to look for appear in this passage. So you have to be judicious, but at the same time you want to make sure that you grab all the important points. Okay, so that's our map. That's our map, and this is what we have to work with when we go into the questions. So number 1, Susie, why don't you read number 1? Okay, what is the minimum tension on the rope? Thank you. So where do we have tension mentioned? Where do we look for tension? Right, I'm seeing that here. There's an FT there. So this tension is just going to be determined by the centripetal force and the frictional force. Okay, so we have a way to get the tension based on that, right? So why don't we start with that centripetal force? So which equation should we use for centripetal force here? Yeah, that's right. We're going to use the one that we know, Fc equals mv squared over r. So let's calculate that first. Okay, and what are the values there? Right, so we have 100 kilograms, the mass of the woman. What's the speed? 5, absolutely right, and that's in our handy dandy little figure here. That gets squared. And what's the radius that we're working with? The radius that we're working with is 10, that's absolutely right. So let's calculate that out. 100 divided by 10, so we have a 10 times 5 squared. 5 squared is 25, 25 times 10 is 250. So we have a centripetal force of 250 newtons. Let's write that Fc again so that we're clear. Now the next thing to figure out the tension is we need the frictional force. Now what else does it say about the tension? What specifically do we need? Yeah, we need the minimum tension. So to get the minimum tension in this equation, we want this to be as small as possible. What do we need to be true about the frictional force? Yeah, we need that to be at a max. So we need FF static max. Okay, and that's simply mu sub s times the normal force, which is mu sub s times mg. All right, so again, what's our mass in this situation? Our mass is 100, our static coefficient is here. So let's just bring that over, 0.1 times 100 times g is 10, of course, and that's gonna be 100 newtons. Okay, so if we go back to our equation, we have a 250 newtons equals the tension that we're looking for plus 100 newtons. All right, so what's my tension? 150 newtons, absolutely. Okay, and that is choice C, thank you. Okay, questions on number 1. All right, right on, so let's go to number 2. Okay, Adam, why don't you read question number 2? All right, we want to approximate the period of rotation. We want to approximate the period of rotation. Now, the first place you might be tempted to look is to come over here and say, all right, well, t is in one of my equations, but I'll bet we can do better than taking the square root, right? So if we try to solve for t, we get a really big mess. And another key here is that we have this word approximate. So we've talked about this in earlier classes. What does approximate often tell you to do? Yeah, that there might be a simpler equation than the one that they give that you can use that's going to make your life a lot easier. So that's exactly what we do in this situation. And t, the period, that's how long it's going to take something to go around once. So what simpler equation could we use to figure this out? Okay, yeah, so the distance traveled is going to equal the rate times time. Okay, in this case, that time is just t, all right? That time is just t. So distance equals, well, what's the rate here if we have a rotating object? Yeah, right, the rate is just the speed at which it's going around. Okay, so we have a d equals v times big T for the amount of time that it's going to take to go around. Solving for t, we get d over v. All right, so we're on our way. We're on our way here. So d, what is the distance traveled around a circle? That's just the circumference, right? Also known as 2 pi r. And what about the speed? We have the speed given, so that's good. Yeah, speed is 5 meters per second, right? V equals 5 meters per second. So that we can plug in. And now r is also given, right? So we're in good shape. Yes, thank you. It's given as 10 here and here. So pretty rad. We've got all our numbers, so now let's just plug and chug. So 2, approximate for pi, absolutely 3. 10 divided by 5, a little bit of math, that's 60 divided by 5, and that's equal to 12 seconds. Just like that, magic. So the answer is B. Questions? All right, looks like we're doing well. Number 3, Janice, why don't you read number 3? Okay, so the key thing here is that the rope is cut, right? The rope is cut. So we get rid of the friction and we get rid of the tension. Well, those were the only two things keeping this thing rotating, right? The centripetal force was provided by tension and by friction. We cut the rope and we reduce the coefficient of friction to 0. No tension, no friction. So what's going to happen to this thing? Yeah, it's going to fly off. So if we have something rotating, if we have an object rotating, at the point where it cuts off, what's going to happen? Right, it's going to go flying off in the direction that it was going. So the vector for velocity at any given point during centripetal motion, remember, is tangent to the circle. And what keeps it rotating is the centripetal force that's pulling towards the center. If we eliminate that force, where's the object going to go? Right, it's going to fly off tangential to the circle. So what's my answer? It sure is D, right? So that's a nice conceptual question that I'm hoping you guys identified as such and hopefully did well. I see heads nodding, okay, not too many dirty looks from the crowd, so that means we're probably doing well on 3. So next, number 4. Lisa, read number 4. All right, we're told angular momentum is conserved, and that's already actually in the passage, right? So that was one of the things that we identified here. LW plus LP is constant, and we also wrote the equations for each of those on our scratch paper. So this is the value that gets conserved. This is the value that gets conserved. And then what are we told here? She moves towards the center, right? So moves towards the center. So which of these values is that going to affect?